All right, we're in Chapter 4, Exponential and Logarithmic Functions. Today we're looking at Section 4.3 on logarithmic functions. So what's the definition of a logarithmic function? Well, a logarithm base b of a positive number x satisfies the following definition. If we have x greater than 0, b greater than 0, and b cannot equal 1. And what it is y is equal to log base b of x is equivalent to, which is 3 lines, to b to the y equals x. Okay, where log base b is read the logarithm with the logarithm with base b of x, or log base b of x, and the logarithm y is the exponent to which must be raised to get to x. Now, if we think about this, y equals log base b of x is equivalent to b to the y equals x. So therefore, y equals log base b of x and y equals b to the x are inverse functions. So we're kind of inversing. We can go from 1 to here and take inverses of each other. And therefore, since the log and exponential functions switch x and y values because they're inverses, the domain and range of the exponential function are interchanged for the log function. So for the log function, our domain is 0, infinity, and our range is in negative infinity to 0. Okay. Now, how do we get from y equals log base b of x to b to the y equals x? Well, we take our base to the y power equals, and it equals x. And so it's b to the y equals x. And that's how we go from there to there. Okay, so we just can go that way. And when we go the other way, what we have to do is say, okay, well, it's going to be log base b of x equals y. And so now it's kind of going a different way, but we have to think about it as then log of base b, so that's sub b, of x equals the y. Okay, and we'll get practice going both ways, going from the log to the exponential and exponential to the log. Now the key thing here is, with our exponential, when we thought about it, that's what it looked like. And so, when we did that, we had, going from negative infinity to positive infinity for our domain, and our range was going from 0 up. Well, now with the log, well, we're not doing that. We're kind of we have to kind of get in the right mode here, and so we're kind of going up like this. And so it's going to be going from, basically, our domain is going from 0 to positive infinity, and our range is going from negative infinity up to positive infinity. So that's kind of one of the ways to think about this. It's kind of the inverse. And so let's go ahead and write these logarithmic equations into the exponential form. Now remember, what if we did this, we had the y equals log base b of x, or if we put the y on the other side, we could do that. And then we said, well, it was b to the y equals x. And so that's how we're going to do it here. We're going to take 10 to the 6th equals that. And so we'll take 10 to the 6th equals 1 million. Okay. And does that make sense? Yeah. 10 to the 6th is 1 million. So that does work. Well, what about this one? Well, here we're going to take 5 to the 2nd is equal to 25. Well, if we square 5, we get 25. So again, that makes sense. Okay. So again, if we want to put our equals in there, that was how we're going to do that. So going this way actually is very easy, and a lot of people can remember that one no problem. It's when we go this way we start having issues. And so, sometimes it's good to look at what we have here, and we say, okay, well, then we have b to the y is equal to x. And so then we can kind of write this back out using that formula. So if we know going one direction, so from here going that way, then if we can write that down, then we can go back that way. So now we have log base what? Well, it's the base is this number here, so that's base 3 of what? Well, now it's of equals, so it equals 9. And that equals what? Well, that equals 2. Now, if we take it back the other way, 3 squared is 9, and that's what it equals, so we have it correct. Okay, so again, now we're going to take log base 5 of 125 equals 3. So if we take it back the other way, 5 cubed equals 125. Yep, that looks good. All right. Now here we have log base 2 of 1/2 is equal to a negative 1. Well, 2 to the negative 1 is equal to 1 over 2. Yeah, that works. 2 to the negative 1 is equal to 1 over 2, because we could take this and say, well, now we're going to take it to the bottom, make it a positive, and now we have that 1 over 2 to the first, which is just the 1/2. Okay, so even though it looks kind of funny having that to the negative 1 here, that's just taking 2 to the negative 1 is equal to the 1/2. Okay. All right, so now what we want to do is we want to evaluate logs mentally. We don't actually need to use a calculator. We're just going to do this kind of right now mentally, as long as we can remember some of our math. And we're going to rewrite the log as a power of b. So b to the y is equal to x is going to be our first step. And then we want to use our knowledge of power, so squared, cubed, roots, etc., and identify the y by thinking about what power does b need to be raised to get that x value. Okay. All right. So what are we going to do? Well, we're going to take 121 to the y is equal to 11. Okay. So what do we have to do to get from 121? And what do we have to raise that to get 11? Well, what is 11? How do we get from 11 to 121? Well, we have to square that to get there, because 11 squared is 121. And so to get from here to here, we have to take the square root. And so that means y is going to be a half. Well, I should say equals, not y to the half, y equals a half. Okay, and so that means the square root of 121 is equal to 11. Does that make sense? Yeah, that's true. And we could also write it 121 to the 1/2 is equal to 11, and that works as well. And so here, this is equal to the half. All right, what about the next one? Well, we're going to take 2 to the y is equal to what? Well, it equals 1 over 32. All right, well, what do we have to do to get a 2 being on top to going down below? Well, if we take it to the negative, we could get to the bottom. Now, what do we take to get to 32? Well, 2 times 2 is equal to 4, times 2 is equal to 8, times 2 is equal to 16, and times 2 is equal to 32. So that's 1, 2, 3, 4, 5 2's to get to 32. And we know it has to be negative, so y has to equal negative 5. I was going to say 1/5, but negative 5. Okay, and so if we take 2 to the negative 5, that's supposed to be 1 over 32. Well, 2 to the negative 5 is the same thing as 1 over 2 to the 5th. And 2 to the 5th is 32, and so that does give us a true statement. So here y is the negative 5, here y was 1/2. And again, we didn't need a calculator, we just had to think about how do we go from one thing to the other. And so this one we first thought, well, how do we get from 11 to 121? Well, if we square it, we get 121. So how do we go the other way? Well, if we take the square root of that, that then gave us 11. And here, well, we knew 32 had to be a factor of 2, so we just kept multiplying by 2 5 times until we got 32. We knew that the 2 then had to go to the denominator because we had the 32 here, so we had a negative 5, and that's how we ended up solving that one. All right, so let's pause there and we'll come back with some more.